In this video, we'll demonstrate the laboratory preparation method of phenacylazide from phenacyl bromide and sodium azide. For this reaction, we are using 2-bromo-4-methoxyacetophenone, which is a hygroscopic compound. Our second reactant is sodium azide, which is an explosive compound. We will put both the reactants in a clean and dry round bottom flask and will be using a magnetic needle for stirring. For weighing of the reactants, we will use a clean and dry spatula. According to the stoichiometry of the reaction, 1 equivalent of the phenacyl bromide requires 2.5 equivalents of sodium azide. We will weigh the reactants according to the stoichiometric calculations. The weighing process is simple. It requires paper trays and digital weighing scale. After placing the paper tray in the scale and before weighing the reactants, we must not forget to tear the weighing scale. Now we will proceed to the reaction setup. First, we will add the phenacyl bromide to the round bottom flask, followed by the addition of 15 ml of acetone, which acts as solvent. We will put the round bottom flask in an ice bath and will use a clamp for support. Now we will on the magnetic stirrer. As you can see, we can adjust the RPM of the magnetic stirrer. Now it is time for the addition of our second reactant, sodium azide. To maintain the low temperature from both inside and outside of the round bottom flask, we will add crushed ice to the reaction mixture. This is an example of SN2 reaction where the azide ion is a nucleophile and the bromide is the leaving group. We know that SN2 reactions require low temperature and polar aprotic solvents. That's why we are using the ice bath and acetone as a solvent. The reaction requires 3 hours for completion. You can see precipitate is forming in the reaction mixture. The next step is the filtration of this reaction mixture, and the residue is our desired product.